The human brain is incredibly adept at processing and understanding the world, but there are certain concepts that challenge our comprehension. One such challenge is the paradox, which suggests that reality might not function in the straightforward way we assume. Recently, physicists believe they may have resolved a paradox that has puzzled scientists for half a century. But have they truly solved it? And what are some of the most intriguing paradoxes out there? Take the Fermi paradox, for example. Named after the Italian physicist Enrico Fermi, renowned for his work on the first nuclear reactor, this paradox tackles the question, where are all the aliens? Given that our solar system is relatively young compared to the rest of the universe, and considering that a civilization could theoretically achieve interstellar travel, it seems likely that we should have encountered extraterrestrial intelligence by now. Some argue that this isn't truly a paradox since we're only speculating about the existence of intelligent life. The Drake equation, developed to estimate the number of detectable civilizations in our galaxy, plays a key role in this debate. The Drake equation uses 7 variables to estimate how many civilizations might exist in the Milky Way. Back in 1961, when it was first introduced, astronomers had no knowledge of planets orbiting stars beyond our own solar system. However, a breakthrough came in 2020 when astronomers analyzed data from the Kepler Space Telescope, revealing that there are over 300 million Earth-like worlds scattered throughout the Milky Way. This analysis showed that approximately half of the galaxy's sun-like stars host rocky planets with habitable zones where liquid water could potentially exist. In fact, planets are incredibly common, outnumbering stars in our galaxy. The upcoming James Webb Space Telescope is set to explore these potentially habitable worlds further, so stay tuned for more updates on that front. Given our new understanding of the vast number of potential habitable planets and possible advanced civilizations, the fundamental question remains, where is everyone? Why is the universe so silent? Maybe we're on the verge of discovering the answer as technology continues to advance, or perhaps we've already been visited by an extraterrestrial civilization without even realizing it. Recent unexplained UFO sightings have sparked speculation that aliens might already be among us. Solid proof of their presence could potentially resolve this enigma once and for all. Next, let's dive into the bootstrap paradox, a fascinating time travel conundrum that challenges our understanding of causality. This paradox revolves around the idea of an object from the future being sent back to the past, creating a loop where its origin becomes unclear. It's a popular theme in science fiction, featured in films and shows like Bill and Ted's Excellent Adventure, The Terminator, and Doctor Who. Consider this example. Imagine you're a time traveler who buys a copy of Hamlet from a bookstore. You then travel back to Elizabethan London and give the book to Shakespeare. Shakespeare copies the book, claims it as his own, and over the centuries, Hamlet is published and reproduced until a copy ends up back in the bookstore where you originally bought it. The paradox arises: who actually wrote Hamlet? Now, for those who missed our video on parallel universes, be sure to check the link in the description. Another intriguing paradox is the grandfather paradox. This scenario involves a time traveler going back in time with the intent to eliminate their grandfather. While it's just a hypothetical, once the grandfather is erased, the time traveler's parent was never born, and consequently, the time traveler themselves never existed. This creates a logical contradiction. If the time traveler never existed, how could they have gone back in time to erase their grandfather in the first place? Imagine everything about you, your family, friends, possessions, and personal history being erased from existence. If this were to happen, you wouldn't have been born in the first place, making it impossible for you to go back in time and cause this erasure. Some scientists propose that in such a scenario, an alternate timeline or parallel universe might be created as a result. For more on parallel universes, check out the link in the description. Another intriguing variant of the grandfather paradox is the idea of going back in time to eliminate Hitler and prevent World War II. Suppose you have a state-of-the-art time machine and decide to intervene before the war escalates. This action, however, would remove the very reason for traveling back in time and erase any knowledge of the need to do so. This creates a paradox where your time-traveling actions might lead to a new timeline where Hitler is absent, but the original timeline still exists. There's also the possibility that this new timeline could end up being even worse. Now, let's consider a different twist involving wormholes with Polchinski's paradox. The late Joseph Polchinski, a renowned theoretical physicist known for his work on string theory, introduced a thought experiment involving a billiard ball sent through a wormhole. In this scenario, if the ball is fired into the wormhole at a specific angle, it could exit in the past and collide with its earlier self. This collision would knock the ball off course and prevent it from entering the wormhole in the first place. Some physicists have proposed solutions to avoid inconsistencies, such as the ball emerging from the future at a different angle, delivering a glancing blow to its younger self instead of a direct hit. This subtle interaction would adjust the ball's trajectory just enough to ensure it still travels back in time, creating a self-consistent loop. Now, let's dive into something that will make you reconsider your understanding of reality: observer's paradox. The observer's paradox is a particularly perplexing aspect of quantum theory, highlighted by Schrodinger's well-known thought experiment involving a cat. It's important to note that this is purely a theoretical scenario and no animals have been harmed. In this paradox, a cat is placed inside a sealed box with a radioactive substance, a Geiger counter, a hammer, and a vial of poison. The radioactive substance has a 50% chance of decaying. If it does, the Geiger counter detects the radiation, triggering the hammer to break the vial of poison, which would be fatal to the cat. Until the box is opened, the cat's status remains unknown. According to the paradox, the cat is simultaneously both alive and dead until someone observes the outcome. This illustrates the idea that observing a quantum system can affect its state, as reality only resolves into a definite state upon observation. You might find this concept strange, but it becomes even more intriguing with the double-slit experiment, one of the most famous experiments in physics. In this experiment, imagine throwing tennis balls at a wall with two slits. Some balls will bounce off, while others pass through the slits. Behind the wall, you'd expect to see two stripes where the balls hit corresponding to the slits. However, when you replace the tennis balls with photons, particles of light, a remarkable phenomenon occurs. If you shoot a single photon through the slits, it creates an interference pattern on the detection screen, as if the photon interfered with itself. This suggests the photon somehow traveled through both slits simultaneously. What's even more baffling is that simply observing the experiment changes the behavior of the photons, as if they were aware of being watched. We know that if an experimenter tries to determine which slit a photon passes through, the interference pattern disappears entirely. This indicates that observing a photon can alter events that have already occurred, raising the question, how is that possible? The answer remains elusive, and perhaps you could be the one to crack this puzzle. The black hole information paradox. One of the most significant paradoxes in physics is the black hole information paradox, which arises from the clash between quantum mechanics and general relativity. According to calculations, physical information might be lost permanently when matter falls into a black hole, potentially leading to a state of complete uniformity. This notion conflicts with quantum mechanics, which asserts that information cannot be destroyed. To illustrate, imagine burning two distinct letters. Reconstructing them from the ashes would be nearly impossible, but subtle traces of their differences would still be present in the smoke and residue. However, black holes complicate this idea. They absorb matter and then, over an incredibly long time, emit Hawking radiation. Unlike the ashes from burning paper, Hawking radiation doesn't carry information about the matter that fell into the black hole. Instead, it's uniform, suggesting that black holes might erase information about the universe. So, do evaporating black holes truly obliterate information, or does it somehow escape as they decay? A new wave of physicists proposes that information does escape via this radiation. They have identified a concept called the quantum extremal surface, an invisible boundary within the black hole's event horizon. This surface is thought to encode the information that has radiated away, evolving throughout the black hole's life in a way that aligns with the idea of information escaping. The resolution to this problem remains ongoing, and we'll keep you updated as new discoveries emerge. Stay tuned for the latest developments.